Good evening, ma'am. This is Monica from CSC second year, roll number 23401805A1. And my topic is sum of subsets problem. Introduction to the sum of subsets problem. The sum of subsets problem involves building subsets of a given set that them up to a specific target value. This problem is a classic example of combinatorial optimization in computer science and mathematics. It has applications in areas like resources allocation, budgeting, and cryptography. Problem definition. Given a set of integers and target integer, the goal is to identify subsets that the total the target. The problem can be represented mathematically as finding a subset S of a set A such that the sum of elements in S equals a given value T. The challenge lies in efficiently exploring all possible subsets to determine which, if any, meet the criteria. Complexity of the problem. The sum of subsets problem is NP complete, meaning no known polynomial time algorithms can solve all instances efficiently. The number of possible subsets of a set with n elements to subset n, leading to an exponential growth in complexity. This complexity makes it necessary to use heuristic and approximation methods for large data sets. Here is the subset of algorithm. For k is equal to 1 to n do, for I is equal to b to 0, if a of I is equal to 1 and ak plus I less than or equal to b, then a of ak plus I is equal to 1. If a of b is equal to 1, then some subset adds up to b. The complexity is big O of b plus 1 of n. Recursive approach. A common method to solve the problem solves using recursion to explore possible subsets. The recursive function checks whether to include or exclude each element, building up potential subsets. This method can be optimized using technique like memorization to store intermediate results. Backtracking technique. Backtracking is a systematic way to explore all potential subsets by building subsets incrementally. If a subset exceeds the target sum, the algorithm backtracks to try different combinations. This approach is more efficient than brute force since it eliminates paths that are guaranteed not to lead to a solution. Dynamic programming approach. Dynamic programming can be employed to solve the problem by breaking it into simpler overlapping subproblems. The approach involves creating a table that tracks achievable sums using subset of the available integers. This method significantly reduces the time complexity compared to naive recursive solutions. Example problem. Consider the set 3, 34, 4, 12, 5, 2 and a target sum of 9. Possible subsets that meets the target include 4, 5 and 2, 3, 4. Solving this example illustrates the sum of subset generation and Sum checking. Variants of the problem. There are several variants of the problem of subsets problem, including 0 by 1 knapsack problem, and the subset sum problem. Each variant has unique constraints and applications, making them important in different fields. Understanding these variants helps in applying the right algorithm to specific scenarios. Applications in real life. The sum of subsets problem has practical applications in financial planning and budget management. It also used in resource allocation problems where limited resources must meet specific criteria. Additionally, it finds use in computer science areas like cryptography for secure data transmission. We are given n distinct positive numbers. The object is to find all combination of weights though sum is equal to weights m. Conclusion. I conclude this problem. The sum of subsets problem remains a critical area of study in combinatorial optimization and algorithm design. While it poses significant computational challenges, various strategies exist to tackle it efficiently. Continued research in this field can lead to more efficient algorithms and broader applications across different domains. Thank you, ma'am.